Hello everyone. Today inshallah I will do a revision on the final exams on the previous two midterms. Of course you know that within the coming exam inshallah it's going to be a good exam. Hopefully you will get the highest marks that you aim for. Before going through this the details of this revision, I would like to say some stuff. First of all, before you go to the through the midterm exams or the final exams or to do whatever, you will have to review these chapters just once, and you will be able to have a complete picture about the details of this course, starting from the matrices, system of linear determinants, vector spaces, linear transformation, eigenvalue and eigenvectors, the dot, cross, and scalar multiplication, and the analytic geometry. In the previous sessions, I've spoken enough about the analytic geometry, and I will start this session by giving you two problems about that came previously in one of the midterms and also on the one of the reset exams about the analytic geometry, about the plan, the vectorial equation of a straight line, how to get benefited, how to imagine. I believe you should really watch the vids of the analytic geometry and how it is applied in this part. This is really very important. So, about the final exam, it will cover actually everything starting from the beginning of our course till the end of our course. The exam will be 3 hours. It will contain plenty of questions. I've already sent you a mock for the final exam, or this exam, which is going to be 3 hours, with a detailed solutions of everything. So you can easily watch this video. Okay, watch the videos about the analytic geometry and its applications as I told you. Study hard, review your lectures, and solve with your hand. It's very, very important to use your hand through your study. So, look to the problem, try to understand it very well, then try to go through it easily or to resolve it once more. I will start with the application of chapter 8, as I told you previously. We already spoke about the plan equation and the straight line equations. What I want you to have in mind about such type of questions is to, first of all, to understand if you want to have an equation of a straight line, you should have two things. First of all, a point on a straight line, then a direction vector in the direction of a straight line. This is really very important. And for an equation of a plan, to form it, you should have, first of all, a point on your plan, at least one point, and then a normal vector on this plan. So these 2 points should be in mind. Okay, let's go through this problem. Let's read it very well. And this is one of the problems that been a part of the third and fourth question in one of the previous midterms. He is giving you that you have common information of the following two questions. Consider the positively oriented orthonormal referential, okay, which is O as an origin such that E1, E2, E3, this is the orthogonal set of vectors. So this part you should remember where we talk this part, you will find the details about the orthogonal basis and our orthogonal set in chapter 7. And let R be the line defined by the following vectorial equation. This is defined previously in chapter 8, this is XYZ. And you have 1, 0, negative 3, and lambda times 1, 0, t. What's really important from this point of view, or from this moment, is to understand and to remember that the first is the point that belongs to your straight line, and 1, 0, 2 is the direction vector that you will need in this straight line. Moreover, consider the plan pi with general equation. He's giving you the equation of the plan. And of course, once you go through once more chapter 8, and just by a look, you will now know that 2, 2, and negative 1, which is the normal vector. Yes, you are right. And you can find any point that you want within this plan. It's really very easy to find. And these are the given. And he's telling you in the following question, choose the options that make the statement is true. One general equation of the plan that contains R and it is perpendicular to R. For such sentences, you don't read it once. You should read it once, twice, 3 times if you want to. Okay, once more, let's go through it. This is a form of a general equation of a plan. It's required to find. Okay, let's do it once more. One general equation of a plan that contains R. So now you know the plan that you are searching for contains a straight line R. Think, how are you going to benefit from this? And it is perpendicular on bar. So actually we are searching for a plan which may be something like this. This is the plan that you are searching for. You have R which belongs to this plan, and also you have another information which states that this plan is perpendicular on another plan, which is given. So let's do it and see how to get advantage of all of this information. So actually, I'm looking for a plan. This is the plan that I'm looking for, which contains R. R, it means a point and the direction vector. So now you have a direction vector which belongs to line R, and also you have a point which is 1, 0, and -3. So this is the point, and that's the direction vector, which is 1, 0, and 2. And this plan is also perpendicular on bar. Once more, the equation of the plan contains R and it's perpendicular on bar. So we can say that pi is like this. For example, just to make things easier for you. So this is the plan bar. What's the advantage of having this information? That the normal vector, which is 2, 2, and -1, this is an indication for the normal vector, which is 2, 2, and -1, which is the normal vector of plan bar. Okay, in order to get the equation of this plan, we should have one point belongs to the plan that we are searching for, and a normal vector. So actually, I will need the normal vector of this plan. This is required. And also I will need a point. You already have the point. Since R belongs to your plan, so you already have a point. Question is now, how to get this normal vector? Once more, get back to the knowledge. This is the plan that I'm searching for, and this is R, which is a straight line, belongs to this plan. I'm looking for this normal vector. See, it is perpendicular on this direction vector. So our normal vector, the one that we need, is perpendicular on the direction vector, which is 1, 0, and 2. And once more, this is the plan that we are talking about, and this is another perpendicular plan, perpendicular on it. This is the normal vector that we need. That's the normal vector of the other plan. They are also perpendicular on each other. So now I have also that the normal vector I want to have is perpendicular on this normal vector, which is 2, 2, and -1. Now it's really very easy. If you remember chapter 7, when you want to have a vector which is perpendicular on two vectors, or orthogonal on two vectors, all I have to do is to do a cross product. So I can do it in multiple ways, but the easiest is just to say that I have E1, E2, and E3. This is the reference set of this frame of reference. The first vector, which is 1, 0, 2. The second, which is 2, 2, and the -1. You work your magic here in order to get the normal vector of the plan that we need or we are seeking. So I will start with E1, eliminating row and column, as you know. we will have 0, then we will have negative over 4. Then I will have to go for E2, which starts with a negative of an E2. Also same way like eliminate the row and column, you will have negative 1, then minus 4, which is going to come up to negative over 5. Same way like for E3, eliminate the row and column, and then you will have just only 2. So this is actually the normal vector of the plan that you are seeking, which is negative 4, negative 5, 2, and now I have the normal vector. In order to write the equation of the plan, as we talked previously in chapter 8, all I have to do is to do the following. This is going to be negative 4 of x, negative 5 of y, plus 2 over z minus, open a bracket, and it's equal to 0. Now the point that I have, which is 1, 0, and the negative 3, so now the point is given. The normal vector is already known, which is negative 4, negative 5, and 2. I will start multiplying them together as we talked previously. So it's going to be negative 4 times 1, then plus 0 times negative 5. Please try to go through the multiplication. As you know, I'm really very weak with numbers. So negative 3 times 2, and then you will have your final value. This is mainly the main steps. As you can see, you can't solve a problem like this unless you really review in details chapter 8. You know what's a straight line, you know what's the plan, the relation between them, how to get a normal vector, how to put a direction vector, the points, what I need exactly to get an equation of a plan, and then it's going to be easy. The answers are 2, negative 4, and the negative 10, so this should be a 2, okay? Negative 4, which already exists. The value of this value, okay, let me check here, please. This is 1, negative 1 minus 4, which is going to be a negative of 4, a negative of 5, 1 negative 1 minus 4, so it's negative 5. And then you will have the C, which is a 2. And for the final result, I believe we will have negative 4. Okay, this is negative 4, and that's negative 6, which is going to come up to negative 10. Once you move it to the other side, you will have it positive. Remark the difference in signs, because as you see, and as we talked previously, if you have a normal vector, simply if you multiply by a negative value, it's going to be the same. So all I have to do is to replace these signs, and I will have 4, positive 5, and the negative 2. Once more, as I told you, you should check all the signs and the algebra with me, and you will find it, okay, correct, inshallah. Once more, I will repeat it with you. So, first, the straight line R equation gives us a point and a direction vector. This is the point once more. This is the direction vector, which is 1, 0, 2. And the second, the plan equation gives us the normal vector, which is 2, 2, and negative 1, and infinite number of points. The second point, we are asking about the plan, which contains R and orthogonal to this given plan. So now I'll start substituting with the values of R, and I have the direction vector exactly like what we said. Then I will start making our cross multiplication with 1, 0, 2, 2, 2, and the negative 1. Once more, this is the frame of reference, IJK or E1, E2, E3, the orthogonal set. This is 1, 0, and 2, that's 2, 2, and the negative 1. Making this multiplication, you will end up having negative over 4, positive 5, and the positive 2. Then you will have positive over 10, which is already okay. Let me check just for the value of z. This is negative 4, this is positive 5, okay? So if we go for E2, once more, I will take negative sign, eliminating row and column, as I told you, negative 1 minus 4, but of course we have a negative sign because of this determinant, so you will have this positive and everything is correct as we said previously. So this is mainly the equation as I told you. Now you will have 5 is correct, negative 4 stands for the coefficient of x, and 2 stand for the coefficient of z, 10, which already the value of the free variable. But instead of having positive 10, you will move it to the other side, so it will be negative 10. What I want you to do is, first of all, you solve it. Be careful about the signs. As you can see, here I missed this sign, and so I have negative 5. So you should check once more for the results. Okay, perfect. So this is the first part of this question. The second part of this question is stating to you, get the distance between the straight line R and the plan by. So once more, this is the straight line R, and that's the plan by. I will need to get the distance between this straight line and between the straight line and the plan by. This is very, very simple to do, because all I have to do is to replace this problem into a distance between a point and a plan. So the required distance is the distance between a point on the straight line and the plan. I need to find the distance between this straight line and the pi, which is perpendicular on the plan that contains R. So it's exactly like finding the point, find the distance between a point and the plan. In order to do so, please do remember, if I want to find the distance between a point and a plan, I will use plan by, and I will use the point which is 1, 0, and the negative 3, which belongs to R. So this is going to equal to the inner product of the vector, as you can see, between A and B, times the normal vector of plan by divided by the magnitude of this normal vector. In order to do so, I will need first to find A and B. So this direction vector you should determine first. So all I have to do now is to get one point, which is B, already exists, 1, 0, negative 3, and I will need just only one point on the plan. So on plan by, I will need just only one point. I have an equation of a plan. Just simply do x equal to 0, put any two coordinates equal to 0, and the sub in the equation of the plan, and get the third one. I will choose to put x equal to y and y equal to 0, x and y equal to 0s, in the equation of pi, which is the given plan. And this will develop z equal to 3, which is a point belongs to that plan. Now I have A belongs to the straight line, and I have P, which is 1, 0, 3. I can get the direction vector, which is really very simple. All I have to do is to get the difference between the coordinates of these 2 points, which is going to be 2, 2, and negative 1. Then directly start substituting in this row. You will have the distance, which is 8 over 3, one of the choices. Direct substitution. The problem is, in order to solve a problem like this, first of all, focus, determine which parts do you really know you will need to have. Start making a plan in your mind. I will use a point, I will use a direction vector, I will get benefited from a normal vector. The normal vector that I'm searching for is perpendicular on this direction vector and the normal vector of the plan as we did previously. Start step by step, and be careful about the signs as I told you previously. I will start now going through this, the previous 2 questions were questions in a previous exam. But I won't solve the previous 2 midterms that you taught this year, which is for the 24-25th academic year. We already have 2 previous midterms, I believe from 23 to 24. I believe we did already solve them. But this one is very, very important just to go through it. I'm not talking about solving the problems by itself, but I'm talking about how to think, how to summarize, how to go around everything. Okay, once more, remember, this is one of the models in the exam, because you had a lot of models through the exam, the multiple choice exam, but this is one of these models. Here, of course, the exam contains 10 questions, so when I start reading any of these questions, you should go step by step, easy, one by one, and start to see if you can find the answers very quick, or you will have to do some work in order to get the results of your or the answers that you are seeking. Okay. Question number 1, indicate which statement or statements are true. He is giving you A, which belongs to a square matrix, n by n, is a Hermitian, so it's a given, and it is invertible, so it's a Hermitian matrix and invertible. So now, at once, try to get in your mind what's an Hermitian matrix, okay? Okay, and also it is invertible. Then, for any alpha belongs to R, the matrix of alpha A plus A minus 1 is also Hermitian. This will need work, so I can't just choose it like this. For the second one, or for number B, for any matrix A belongs to an n square matrix set n of n, and for alpha, the matrix alpha A minus 80 is a hemisymmetric. Hemisymmetrics mean it's a skew symmetric matrix. Okay, I will need to remember what's the condition for skew symmetric matrices. So, okay, so this question mainly focusing on matrices, about the types, about how to discover a skew symmetric matrix. The number C, the matrix, which is 0, 1, 3, 0, negative 2, blah, 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 is in reduced row echelon form. This answer can be done really very easily from the definition, which once you look at it, yes, it's on the reduced echelon form, so you are in a very good shape. Okay, so number C is correct. For D, there exist matrices AB belongs to m by n, such that A is invertible, B is not invertible, but AB, oh, hold on. This is crap. This is crap. There is something wrong in this statement, because he is stating that there exist matrices A and B, which are square matrices, such that A is invertible, but B is not invertible. Since B is not invertible, then AB is not gonna be invertible. They are not gonna be inversible, because if you have two matrices and both of them are invertible, their multiplication will be invertible. So as you can see, A and B, it will need extra work from you. But C and D from the definition, you already gained their marks. Any zero matrix is symmetric and is in reduced row echelon form. This is a very tricky question. It needs you to be a good reader. You should read very well the lectures in order to understand the form that he is trying to push you around. Okay, let's do them step by step. For A, B, and D, for A, B, and C, they are all correct. We will go through them. For D and C and E, they are not correct. And of course, you know that you have penalty if you choose a wrong answer. So please do focus. For the first question, it's really very simple. A matrix is Hermitian. What's the Hermitian matrices? The Hermitian matrices are those types of matrices when you get its conjugate and transpose, it's going to be the same. So the conjugate transpose, I will say that it's A star, as we talked previously in lectures. So what I want to show now is A is equal to A star. If you have the matrix equal to its conjugate transpose, then the first statement is correct. Simple. So if I have, and also he gave me that A is inversible. So A minus 1 conjugate transpose is going to equal to the conjugate transpose then having the inverse, which means that it's a matrix, Hermitian, and it's also invertible. So this is the first point that you should put in mind. Now, I want to prove that for alpha A plus A minus 1 to be Hermitian, it must be the conjugate and the transpose of the conjugate will be the same. This is actually what I want to prove. So if you look closely to this statement, to the last statement, this is what we want to prove, which is very, very simple. All I have to do now is to start analyzing the left-hand side, which is going to lead to alpha A, okay, conjugate transpose, which is going to equal to A minus 1, the conjugate transpose. Taking advantage from the statement in black and making a substitution in this statement, we will find our goal simply. Look to the next slide. All of this I will repeat it once more. So once you come to the next slide, this is what we reached. This is the last step. Once more, taking advantage from alpha A minus transpose of a conjugate equal to alpha of A, because A is a Hermitian matrix, using advantage from these two substitutions, and by the use of this equation also, I will have that alpha A equal A minus 1 star, that's alpha A equal A minus 1, which proves the relation that we want, which means that it is a Hermitian matrix. So, as you can see, all I have to do is to go step by step, starting once more from the left-hand side, just taking the advantage of the definition of the Hermitian, and also the advantage of A minus 1. This is the result that we have reached, the final one, as you can see. So this is mainly the last equation that you can see from the cursor. Now I will start taking advantage from what we achieved previously. From this equation, I will start replacing A minus 1 conjugate equal A minus 1. And for alpha A minus 1, it already exists, alpha A. So it's proved. Now we have our proof for this part. Okay, for problem number 2, or for question number 2, he's asking you about alpha A minus A transpose is a skew symmetric matrix. And this is much similar. Also, you will do the same, but with remembering all the properties of the, any ideas about the transpose? So all I have to do for a skew symmetric matrix, let's remember, a hemisymmetric matrix means a skew symmetric matrix. How to know that your matrix is skew symmetric? Yes, exactly right. Remember, symmetric matrices A equal to A transpose. But skew symmetric matrices, it will equal to the negative. So all I need to prove now is alpha A minus AT should equal to the negative of their transpose. And this is going to be a skew symmetric matrix. Once more, if you would like to remember the skew symmetric matrices, that's an example for a skew symmetric matrix. You have the diagonal equal to 0, the upper triangle, and the lower triangle, they have in different sides. Okay, perfect. I will start, as I told you, what's required in this problem, and this is also something you should put in mind. He's giving you the statement as math word problem. I want you to write it in mathematics. So now I know that A equal negative A transpose. This is gonna be the condition for skew matrices. So if you want me to prove that alpha A minus AT as a skew symmetric, it means that I want to prove that negative alpha equal A minus AT. So this is actually the statement that I'm going to do. I will start once more from the left-hand side. Okay, transpose of alpha A minus AT. That's a transpose of this statement. Of course, alpha belongs to R, so its transpose is going to be the same. So it's alpha. Then start moving transpose on the matrices that you have. So A is going to be a transpose, and the transpose of a transpose equal to A once more. Now we are reaching alpha equal to AT minus A. All I have to do is to look to this statement and what we need to have from the beginning of this problem. Take minus sign as a common, and now it's exactly what we wanted to prove previously. So it's correct. So B is correct also. For number C, we don't have to do extra effort, as I told you at the beginning. It's just the statement in between your points. So it's reduced echelon form, it's correct. For number D also, you don't have to exert a lot of effort. If A and B are invertible matrices, then AB is also invertible matrix. But you have the condition, both of them, they should be invertible. Here, he's giving you A is invertible, B is not invertible, so statement number D is not correct. For number C, and this is really very tricky, it is asymmetric and in echelon form, not in reduced echelon form. He's right about the last question, so all he has to do, see if we removed the word reduced and we make the statement any zero matrix is a symmetric and in row echelon form, it's going to be correct. But once you put reduced echelon form, it's not going to be correct. Okay, here's why. I will start by the following, giving you the definition from your slides previously. Let A belongs to n by n. The matrix A is in row echelon form, denoted by F and E, if A equal to 0, or if the pivots of A are in the rows 1 up to S, blah, blah, blah. As you know, so that's the condition for an echelon form. To have a reduced row echelon form, which is the part that you are asked about, a matrix in reduced echelon form, denoted by FER, if it is in a row echelon form with all pivots, you should have all pivots. All pivots, it means ones on each row. If there is any equal to 1 and all other elements in the column where there is a pivot equal to 0. Reduced row echelon form algorithm of A, which is n by n, it's a non-zero matrix. This is why the previous statement is correct for echelon forms, but it's not correct for a reduced echelon form. This is the end of question 1. Before going to question 2, please, I beg you, read the question more than once. Start to determine which parts they will need extra effort from you. Maybe within these multiple choice questions, you will find some of them easy to answer just from the definition. Like what we saw previously in the problems in C, D, and E. If you look A and B, they needed to be proved. So they needed extra efforts from you. But C, D, and E are really very simple. Once more, this is the question, the second question. Let's read it together. First of all, also determine in which part, in which chapter, it will help you a lot. For each alpha belongs to R and for beta belongs to R, consider the system of linear equations over R, whose augmented matrix, stop. He's telling you about the system of equations. And he's giving you one of the most, I know you are very skillful about dealing with augmented matrices. So, this is the augmented matrix. It's giving you two unknowns, alpha and beta. We did that plenty of times previously. So, please go step by step. Okay, under these conditions indicate which statements are true. Alpha doesn't equal to 0, beta doesn't equal to 2, then the system is a consistent system with a unique solution. We can do it. We will have to do extra steps by getting this matrix on the reduced echelon form or in the echelon form, then we will make these substitutions. Also, for B, is talking about alpha equal to 0 and B equal to 3. For C, beta equal to 2. Number D, alpha, no. I will have to solve it from the beginning. So this question will need, first of all, is to put this matrix on the echelon form. Now let's start. This is your matrix given. I will start with adding the first row on the third row. So start by this. 1 and negative 1 is going to equal to 0, negative 1 plus 1 is going to equal to 0, blah, blah, blah. So I'm adding the first row to the third row, as you can see. Now, I can multiply the second row by a negative and add it on the fourth row. And this is the final form of the echelon form. I've already reached the echelon form. Now I will start substituting. This system, first question, if alpha doesn't equal to 0, so alpha doesn't equal to 0, beta doesn't equal to 2, so if you look, please do look to my hand, you will find your matrix, it's gonna be of a rank over 4, which means the system will develop a unique solution, as you can see. So for number A, if alpha doesn't equal to 0, beta doesn't equal to 2, you will have a rank of 4, which equal to the rank of the augmented matrix, which means you will have a unique solution. Okay, for number B, once more, I will have to get back to my echelon form. So once more, this is the echelon form. I will start now by putting alpha equal to 0 and beta equal to 3. Once you start substituting, you will have the following. Alpha equal to 0 and replace beta by 3. This is the main form, or this is the final form. Try to get the reduced form from this matrix. So simply, I can multiply the second row by -1 and add it on the third row, and then multiply also the third row by -1. You will get the last matrix that you will see. Now, once more, I will start taking the pivot of the third row and making the elements above it in the second and first row equal to zeros. So this is going to be the final result. If you look to this matrix, I will start reading. Alpha equal to 0, beta equal to 3, then the system is consistent and underdetermined with a degree of indeterminacy of 1, and the solution set of the system is given. Yes, till the time being, everything is correct. Yes, it's underdetermined by 1. You have 1 degree of freedom, and let's start. This is the solution which is going to be. For x minus y, it's going to equal to 5. So simply I can put it on this form, x equal 5 plus y. I don't have y, the second row does not exist. I don't have y, the pivot of y. So I will consider y as the free variable, so y equal to c. And from the augmented matrix, the last matrix that we have z equal to 3 and omega equal to -3, exactly as you can see. Okay, now start reviewing the results that you have with what's given. W equal, the fourth component equal to -3, the second component is 3, the third, once more from the left right. The first component is 5 plus c, the second is c, the third is 3, and the final one is -3, so number B is correct. Once more, I will need the echelon form. Here we go, that's the echelon form. And he's telling you if beta equal to t, I'm in number C, if beta equal to 2, I will start substituting by 2. So please give a good look to